Hi guys, good morning. We are in the 26th session of Oracle 12c Core DBA for Beginners course, and in this session we are going to actually kickstart the 17th chapter, where we are about to start the CDB part. So as we discussed, there will be almost 10 more sessions, including this session, to complete the architecture part of CDB. That means we are going to touch base whatever we have learned so far, and then we are going to see, how the topics that we have covered so far is different in CDB architecture. So as I told you in the last session, we are going to do a summarization of what we have learned so far in last 16 chapters. We are going to do that because when we will do is when we start the installation of the database again, we have the database installation now. So for the database installation to complete, it would take some time. So meanwhile, we will be completing the review part. So that's the agenda. So this particular chapter is again divided into two sessions. We cannot complete this complete chapter in one session. So it is divided into two sessions. The first session will give you the introduction of containers and also the installation part. The basic benefits of containers, and also how do we do the database checks. So that is what CDB level database checks. That is what we are going to cover in this session. So the next session will completely cover the architecture overview of CDB and what are the additional processes that are involved in CDB architecture and what are the additional memory processes involved in CDB architecture. So these are the things that we are going to cover in this architecture part of CDB. The name is given as 1. So I almost have, I think, 4 to 5 chapters, probably with architecture 1 or Oracle CDB architecture 2, 3, so on and so forth. So we are going to face all of them, as we keep progressing. So let me give you the introduction of what is CDB. CDB stands for Container Databases. So if somebody says containers, they are speaking about CDB architecture. Okay. So what is a CDB architecture is nothing but, as we have learned a non-CDB architecture so far, that is we have installed OraDB database and we have been using the same database. Very similarly, until 11g R2, you can install next database also in the same server. You can install third database also in the same server, like OraDB 1, OraDB 2, OraDB 3, OraDB 4, so on and so forth. Using the same software, you can install multiple databases on the same server. Each database will behave like a non-CDB database according to the knowledge that we have gained so far. What is the challenge there is, let me write down that here. In 11g R2 or until 11g R2 to create multiple databases, okay, you will need to run dbca and install the databases required in the Oracle home. Required using the Oracle home software which is installed. So what happened? When you do this, what happened is, one thing is you are duplicating, background processes, right? So that means each and every database that you're going to create will have its own set of smon, pmon, logwriter, archiver, whatnot. So you are going to duplicate all the set of background processes when you are installing multiple databases on the same server and also the same version. That is what I'm speaking about. And then you are complicating management. So that means if you want to manage space, if you want to manage the performance, if you want to manage the backups, if you want to manage whatnot, data movement, all of that becomes complicated once you install multiple databases of same version on the same database, right? That is what you're doing it. But what if you can install one database as a parent database and then n number of child databases you can basically install using the parent database? That's the idea behind containers. So all the child databases are called as pluggable databases. That means there will be one container database, we call it as CDB. This CDB database can actually accommodate n number of pluggable databases. So you no need to install again and again by running a DBCA to install a new database. You can once install one CDB database and you can add in a database, remove the database as simple as one click. So that means you are saving a lot of time. Here you are spending a lot of time, right? Lot of time. I mean every moment when you are installing a database, right? But in containers architecture, what happens is it is as simple as plugging in a a USB device into a system and plugging out a USB device out of the system. So it is as simple as that to add a new database to the architecture and to remove any existing database in the architecture. And this is the reason why these container databases play a vital role in the Oracle Cloud technologies at the moment. So if you are going to buy an Oracle Cloud database as a service, the Oracle will be giving you one of the pluggable databases. That is why, that is how the Oracle is, optimizing the hardware. So the reason behind these containers is nothing but the, evolution of cloud technologies. You can call it that way. So as the cloud technologies has evolved so much, there should be a simplicity in adding a database and removing a database on one click. This was the statement behind, developing this particular architecture. So now as a, overview, as I have to cover this introduction as a summary, if I have to summarize the containers introduction, there will be one database that you are going to install. We are going to call that as container or CDB or root container or container. So these are the names that people will container. These are the names that people would often refer, or whenever they are trying to speak about container databases and pluggable database. So there will be one parent container or a root database to which you can attach a database, you can detach a database. That means you can create a database on a fly, you can remove the database on a fly. All the databases that you are going to attach and detach to this particular parent container are called as pluggable databases because they are easily pluggable, that is plugging in and plugging out, both is possible. So all these pluggable databases are the set of databases which are logically connected to that particular parent container. Okay, that is one of the important things that you need to remember. Now, to help you understand this particular database plugging concept and all of them, I would take the example of non-CDB database again. So inside the non-CDB database, I'm sure we know how to create a user. And if a user is connected to that particular database and if he creates n number of objects, all those objects will be residing only in that user, right? And very similarly, we can create user 2 also in the same database, right? And again, user 2 can connect to the database and he can create his own set of objects. Now, these users are plugged out as a separate database. That's it. So you can consider each pluggable database as a logically created schema inside non-CDB database. So when you are working on non-CDB database, you have a schema, right? Schema is nothing but a user with set of objects. Now you can consider a schema can be a pluggable database. I'm just relating it so that you can understand it better. But it is not exactly. Inside the PDBs also you can create users. No problem for that. But for you to better understand, it's a logical relation of all the PDBs to one container database. That's it. And each pluggable database will behave individually, but they are going to share the same infrastructure resources across all the PDBs which are connected to the same CDB. So the CDB is the root. It is going to consume CPU, it is going to consume memory, it is going to consume IO, and all these three resources are spreaded across the PDBs that are created. Okay, this is how a CDB architecture has been evolved. I'm just giving you an overview here, but we are going to look at this closely as well as we keep going forward. So what is that, we are going to avoid with this CDB architecture? Number of background processes, because we were duplicating it here. We avoided that redundancy. We have avoided memory allocation also, that means you are utilizing, more memory. It might be necessary or it might be unnecessary as well. So memory allocation is what we are reducing, and the metadata of dictionaries, right? You can call about db underscore dictionaries are being duplicated, isn't it? Because it will also occupy some space, right? Are being duplicated. So all these problems, if you want to install multiple databases of same version on the same server, you can reduce all of them by following a CDB architecture, right? So a CDB architecture, in case if you are already a working DBA, the architecture of databases would be like this. Each database would be dedicated to one particular application. It can be an OLTP application or OLAP application. Okay, OLTP is a transaction application, OLAP is a data warehouse application. Now, in CDB architecture, each PDB can be attached to an application, right? In non-CDB, complete database will be attached to one application, but in container environment, each PDB can be attached to one environment, correct? That is the reason why they have created this particular flexibility to help you attach any pluggable database or detach any pluggable database on the fly. All right, so that is what the introduction you need to basically know. So let us quickly install a CDB database. For installing a CDB database, definitely 12c software is required, which we have already done. In case if you are following this particular session from this chapter, please do install as we discussed in session number 1 and 2. That is, software installation is also part of those sessions. So you have to install the software only, then come back to this particular session and then run dbca to start the CDB database installation. So I have started my VM. As you can see, this has been started already. Okay, so now let me directly connect to my PuTTY. Now I'm not going to start my database, that is OraDB. From now we are going to install another database which is of CDB database environment, and then we are going to use the same. So I will set the environment variables, that's it, because I have to run dbca. And guys, if you remember, we have configured PuTTY to run xming, right? So that port forwarding has been done and UI forwarding has been done, so that in case if this PuTTY terminal has to run something on a UI basis, xming has to run. So just go to my Windows, I am going to type xming, and this is my software. I am running this. So I can have my xming here. So it is running. So now as my xming is running, I can directly type dbca. So let us wait until my installation wizard, database configuration assistant, is started in my xming. So it is loading here. And then we will start quickly with the database creation. So CDB container is nothing but creating a database which is of CDB type. That is nothing but container type. So as you can see here, we are here in this session to create a database. So as you can see, I will leave this option here, create a database, and then next. I'm going to go with advanced mode. So just click on the advanced mode. But in non-CDB environment, we have basically selected default configuration. But I wanted to show the advanced mode also. That is the reason I'm selecting this. Else we can go with default configuration as well. So go to the advanced mode and take a general purpose transaction processing template. It's only a template. We are going to modify all the default values going forward. And then this is the database name. So the database, this is nothing but your container database name. That is the reason why I am giving OraCDB. Now, because I wanted this to be created as container database, I am telling that create this database as a container database. That means you can also tell how many pluggable databases to create on the fly, right? Once this root container is ready, these two pluggable databases will also be part of the container called OraCDB. So Aura CDB is the database created, and Aura PDB 1, Aura PDB 2 will be my two pluggable databases created to the same container. So it is like for one system you are attaching two pen drives, right, or flash drives. That is what it is doing. Your system is nothing but your Aura CDB. That is nothing but your container. That is the root. And then your pluggable databases are nothing but your pen drives. And your pen drives will use the same system resources, right? The CPU and memory and IO, whichever is attached to your system, the same resources will be used by your pen drives as well, or flash drives. You can relate it like this as well. That is how I keep learning. Now, next. And I don't want to configure any enterprise manager at the moment because it's an advanced topic. Enterprise manager is a UI based administration tool. So I'm not going through this in this curriculum at all. So just unselect it and click next. And you know sys and system already. There is another username called as PDB admin. That comes now. So you can create this one password for all these administrative accounts, because PDB databases has come in. So PDB admin is a new username that is available for administration purposes of your PDB databases. So I have used a common name for all these three users. Now next. And there are already two listeners configured. In case if you want to create any other listener, you can create it. But instead, I'm telling add the Aura CDB database container database to the same listener called as 1521. Else you can click on create new listener. You can give a new listener name and any other port number apart from 1524 and 1521. You can do that one also. Next. So my data file should go to file system, that is true, but it should go to a location called as /Aura data. Okay, and it will be OMF Oracle managed files by default. And then recovery file storage, I think you no need to worry about it. But yes, fast recovery area is something that we need to configure. So just say Aura data, and I will enable archiving later, not now. So let me click next. Now this is where you can configure vault and security in case if you have some idea, but I'm not doing it, because it's not part of this curriculum and not the discussion, because those things are again, lot of topics to discuss around. So just click next, and this is where you can give the size of SGA, PGA in case if you want to use automatic memory management. Okay, else you can also specify SGA separately, PGA separately, and then sizing. These are the minimum number of processes. You can increase it in case if you need it. Character set, I'm using the default one, but basically you need to check with your application what character sets it has to support. You have to use that. And then connection mode is dedicated server architecture. I think we have discussed about dedicated and shared server architecture earlier. The difference is in PGA. That is nothing but the process architecture is the difference. That's it. Coming back to this, I'm leaving these defaults and then going to the next stage. Now I want this to create it. So it is going to run some prerequisite checks. Okay, and something has been popped up. So disk space check. So what is it? So Aura data does not have enough space. Required space is 8430, but available space is 6900. That's fine. It is 6 GB, but that's fine. Let me go forward because it's not a showstopper. It's only an alert because it's an yellow mark. If it is a red mark, that means it is going to block me, right? That's fine. 6 GB is more than enough for me is what I feel. So I'll take okay. These warnings should be fixed in order to proceed. I will tell ignore, right? And then go. Okay. And this is a summary. As you can see, Aura CDB is the container database, and yes, it is a container database. That is what we are creating, and in which we are creating two pluggable databases with a prefix of Aura PDB. That means Aura PDB 1, Aura PDB 2. These are the databases as a pluggable databases will be created. So this is a summary that you can check. You still have sysocs 1, system, undo, users and temp. These are the table spaces, and two control files are being created, multiplexed control files and also multiplexed read log groups as well. Now click finish. So now as this container database installation progresses and before it hits to the finish, let us come back to our discussion and then see, where do we stand, and what is that, what are the topics that we have covered already in 16 chapters is what. Let us do that. So the best way to go to top is this. This is what I feel. Great. I'm sorry. Okay. So let me come here and then show you what was the chapters we covered. So far in last 25 sessions, these are the chapters we covered. So let me start from chapter number 1. So chapter number 1, we have covered, non-CDB database installation basics. We have covered enterprise Linux installation, network configuration, what configurations needs in PuTTY to enable Xming, and then what are the OS prerequisites and why these prerequisites are required is what we have covered. And we have installed softwares and also networks and the database. And here the database that we have installed is non-CDB. That means we have deselected containers. That's it. And then we have also understood what are the purposes of all these files that we have been using in day-to-day activity, right? And then we have also seen how to start, stop, listener and database every day when you want to practice. And quickly we started with the architecture part of non-CDB and database. And this non-CDB database, we started with the overview of the architecture. We divided that into database and instance. And within the instance, we have memory architecture and process architecture. So this particular chapter number 2, we have covered memory architectures. That is what we have completed. And chapter number 3 covered process architecture, right? So process architecture involves background processes, PGA as well. And then what are the categories of processes available inside the database is what we covered. And chapter number 4, we covered the storage and in-memory architecture concepts. In-memory cache is something new in 12c, and storage is nothing but what are the table spaces, what are those terminologies, what is the physical file on the operating system called data file, and how is it logically related to a table space. You can always create a table space. Without creating a table space, you cannot create a data file. So all these logics we have to derive from this chapter. And then we have connected the dots. This was very, very important activity. Whatever we have learned from chapter number 2 to chapter number 4 end, we have connected all those dots here. And then fifth one was initialization parameter files. This is one of the key file which is very important for the database to come up. So this particular file will have all the you can call them as configuration related information. That means what should be the size of memory, what should be the size of the processes, where are the control files located, what are the dispatcher's name, uh, and where is the Oracle base directory, etc., etc. So all that information you have in initialization parameter file. So we have understood pretty much regarding this file and how important it is and at what stage it is useful. And then we have also understood differences between dynamic and static parameters, and we have also performed certain exercises. And also we have also seen SP file and P file also, and we always prefer database to run with SP file. We call SP file also server parameter file. Chapter number 6, we covered startup and shutdown options. That means, whenever you are starting up the database, what are the phases involved? And when you are bringing down the database, what are the options available? So that is what we covered here. So when you bring up the database, no mount is when P file will be used or SP file will be used. Mount is when control file will be used. Open is when all the data files and redo log files will be accessed. And we have also seen what are the dynamic performance views and data dictionary views. And DDL and debug log files are something new in 12c. You need to mark it here, and then we know why do we use it. So in case if you want to monitor all DDLs happening inside the database, you can just enable this DDL, and then you can find out all the DDLs which are running in the database in that log files. And then 7th chapter we have covered networks. So network is a key component which will enable the applications to connect to the database. So via a TCP IP protocol over the port number. So always a network connection is via a port number, that is where the internet world is connected, right? So even a web page will speak on the port number called 80, right? So that is how, and if it is an HTTPS web page, it will speak on the port number 443. So, the world is connected across the servers, over the network. And if it is over the network, the port numbers plays a vital role. So we discussed here what is the component that will help applications to connect to the database. We call it as listener, and each listener will have what are the things? Three important things. One, what is the database name, what is the service name, and what port number it has to hear, right? Using these, details, application server will try to connect to the database using username and password. And we have seen what are the available options once a listener is up and running. With respect to the client, that is nothing but your application, what are the different available methods to connect to the database is what we discussed. Chapter number 8, we have went in detail on the storage architecture. So we have created certain table spaces, we have removed them, we have resized them, and we have viewed the table information. We have understood what is exactly the Oracle managed file system when it is compared with non-OMF files. And we have listed down the activities which you would see in real-time activities course. But another type of file system which Oracle is proprietor of is ASM. So that's the software that is best used for better optimized IO, for rack purposes mostly. But having said that, rack, it doesn't mean that you cannot use for standalone databases. You can use for standalone databases as well. And then ninth chapter we have covered user security. That means if an application has to connect to the database, it should have a username and password. So how do you create a username and password? How do you limit the privileges? That means any user on the database cannot have the access to the complete database, right? He should be able to do his job. That's it. In case if he is trying to do another job that is nothing but admin job, it should not work. So we call them as privileges, and privileges can be controlled with the help of roles. And then user, related session information and details can be controlled with the help of profiles. So we discussed all of them in chapter number 9. And then chapter number 10, we discussed about the undo, because undo is very important in any of the applications nowadays. So if you perform an action, in case if you want to come back from that action, undo is something which is useful. So to help you with this particular feature, there is by default called undo table space installed. So we have understood why undo table space, how does it work, when you delete a row, what happens, when you do an undo, what happens, all of that we discussed here. And very importantly, we have seen the difference between undo and redo. You should not confuse. Redo is to redo the same thing again and again, but undo is nothing but the action that you have done, the reciprocal is called as undo. So coming back to the earlier state is called as undo. And 11th chapter dealt with data concurrency. That means no two users can modify the same record at any point of time. So at any given point, no two users can modify a same record. Record is nothing but the same row. That is what we call it as consistency. So in case if one user completes the transaction, yes, the second user can now go and access the same row and modify the data. That is definitely possible. But at any given instance, no two users can change the data of the same row of any table. This is what called as data concurrency. This is basically possible with the help of locks and waits. So locks, blocks, deadlocks, and waits is what we have discussed here. And 12th one, started giving you something about the performance tuning maintenance. And we have introduced what are the terminologies involved. How do we plan for better performance? You will often hear instance tuning, waits, SQL tuning, optimizer, statistics. So statistics, SQL tuning, instance tuning, memory tuning, all these terminologies, what are they mean actually is what we have discussed here, right? And altogether performance tuning is a separate, topic to discuss. That's the reason there is a separate course available on our website, orskill.com. And 13th chapter, deals with, backup and recovery concepts. Excuse me, I think installation is done. So we will quickly wrap this up. So backup and recovery concepts are, you have to know why backups and recoveries are needed. So that is the reason why this chapter covered the basics of it. So what happens to instance when it fails? What happens to database if it fails? What happens if user performs an error by mistake? So how do we recover back? All of that we discussed here. And then chapter number 14 spoke literally about how do we take backups on a day-to-day activities. We have started understanding a very important tool called as RMN. Right? We have created backups, we have seen the backups, and we have also ran couple of tests to do this. And chapter number 15 covered recovery. That means once if there is any failure in the instance, how do we get the database back from the backup that you already have taken? So that is what called as instance recovery. We have covered all that here. So when it is loss of a control file, how do you recover it? When you lose a redo log file, how do we recover it, etc., etc. And in the last chapter we actually completed refreshing data. So in refreshing data there are three utilities called SQL loader, external table, and EXPDP, IMPDP, data pump. So these are the three different topics that we have spent enough time with one exercise for each topic to understand why. SQL loader is basically used to load the data which is in the external file into the database tables. External table is something different. You always have the data outside the database in a flat file. You can query that with the help of an SQL statement inside the database. That is what external table is. Data pump is another utility which is mostly used to move the data from one database to another database. Might be on the same server, might be on the different server. Alright, that is what we did in chapter number 16. So let us come back to this. So the installation is done. Let us perform some checks now. So the first check is not here. Just click on close. Now the first check is check the background processes. How many SMONs are there? There is only one SMON. But how many databases are there? Aura PCDB1 and Aura PDB2. These are the two databases created, right? But what is the background process? There is only one background process with Aura CDB. Is there any background process with the name Aura PDB? Let us check for your verification. There is nothing, right? So we are going to discuss this in the next session anyway, regarding the background processes which are related to container databases. How is it different? We are going to definitely spend a lot of time there. But yes, this topic is 17.3 is database checks. I am helping you to do that. So now let me set the environment variable of new database called as Aura CDB. Now you can directly connect to the same thing called as SQL plus /s sysdba. And now if you just fire show container underscore name, show con underscore name, you will see that you are connected to the container called as CDB $root. This is the reason there are multiple names to container databases. People call CDB, people call root, people call container. All these three means the same root database. Now how do we check if the pluggable databases are available? So what you can do is you can just say this $database. We have already seen this dynamic performance view. You can see that Aura CDB is the database. It's a CDB architecture. And all the root containers will have the container ID called 0. So container ID is a unique ID given for all the pluggable databases. And the root database, that is nothing but the container, will have the container ID 0 always. Okay. Now let us check here the instance name. What will be the instance name? It is still Aura CDB and it is open, and instance is basically directly connected to the root database. That's the reason you have container ID 0. Now, one logic that you need to understand is why did I ask to check the listener status? Let us do that. lsnrctl status. Now if you see, you have Aura PDB1 as a service, Aura PDB2 as a service. See it? And whenever you try to connect to this service Aura PDB1 and Aura PDB2, it is going to help you connect to Aura CDB database only. So that means these Aura PDB1, PDB2 databases are nothing but services that are available in your listener which will help you to redirect to Aura CDB only. So Remember this point. If you want to connect to PDB databases, it is through a service name only. You can connect to a PDB database over the listener network. This is how the difference is. I'm stressing in this point. You have to understand. You have to remember this difference. In case if you want to connect to any PDB databases running, one of the available options is by using service name of the listener and then connecting to that particular pluggable database. This is one of the available options. I'm not saying that this is only the option. This is one of the available options. Now check this. So you can also check these services with the help of $V services dynamic performance view. You see that there are background processes and sys users. You can ignore this. And XDB, you know that this is for shared server architecture. We are not using it. You can see Aura CDB for $V services container ID is 1. You can ignore it. But see here, Aura PDB1, it's a service. Aura PDB2 is also a service for your Oracle database. So that is the reason you can find this Aura PDB1 and Aura PDB2 in your listener, but you don't find any background processes on these names. Right? Now there is a new dynamic performance view called $V PDBs. And you can check what are the list of PDBs available. Now if you see, there is one PDB that you cannot touch called as PDB seed. So PDB seed is by default a template which is available for you when you create a container database. So using this PDB seed, you can basically create n number of pluggable databases on a single SQL statement. So just like your container root, this PDB seed is also like a seed using which you can basically create n number of pluggable databases, is why the name is given as seed. You cannot do anything with this database, it will be fixed. But this database you are going to use in case if you want to create multiple pluggable databases like PDB1, PDB2, PDB3, etc. etc. Now you can see PDB1 is read write, PDB2 is also read write. So these are the pluggable databases which are created. Now you can see what are the families of CDB and PDBs. Let me show you. So you can see that in CDB and PDB, in the CDB, what are the PDBs connected is what this information will tell you. Each PDB has also got a database ID. In non-CDB database environment, each database will have a unique database ID, right? But here in each CDB also you have a database ID. You can get that information here. Okay, coming back to our doc, and just check how many number of redo log files are there. Whether redo log files are there for PDBs as well, just check. No. There is only one set of redo log files and all are connected to container ID 0. That is nothing but your root container. Please remember these differences. We are going to touch base them again. Okay, this is only a check file. I'm just helping you to check. So these are the control files created as per the installation. And now check where are the data files available. Now see here, earlier we have used db underscore data files, right? Now you start using cdb underscore data underscore files. Alright, so let us check that. What is the difference? See here, not just system sysocs, not only for container ID 1, for container ID 3, that is Aura PDB 1, you have system, sysocs and users. And for Aura PDB 2, that is container 4, we have system, sysocs and users. You can see these directories, right? Now this is something that you need to mark it up, and we are going to discuss that in the next session. So each and every pluggable database will have his own system, sysocs table spaces. If you observe another difference, you will not have undo table space for each PDB. Undo table space is only one for all PDBs attached to a container. And temporary table space, let us check in case if I have got that. But let's check. What if you go and query DBA data files now, you will find only this for the container that you are connected to. We are connected to the container called root. So for that root directory, whatever data files are attached, you can see that here. So if you query DBA data files, you will get the data files attached to the container you are connected to. But in case if you want to see all the data files, you have to use cdb underscore data underscore files dictionary. Now you can see under cdb underscore users, just like db underscore users, you still have cdb underscore users. There is a system user which is created on each container. See, container 1 is your root, 3 is your pdb1, 4 is your pdb4, sorry, pdb2. And you can see here there is something called common. That means this system user is like a global user. You create it in the root container as a global user that will be available in all the pluggable databases on that server. That is the reason here you can see as common. We are going to discuss that when we speak about users. Okay, so you can discuss or you can check here. So these are the list of global users. So that means all these users are available across all the PDBs that you are going to create. So common equals to S will give you the global users. So global users and local users. These are the terminologies that we are going to speak about when we discuss users of CDB environment. And list of local users. Yes. This will give you what are the list of local users which are not common. That means PDB admin is the user which is created in container 3 and container 4, which you cannot basically use for any other databases. So that is the reason why, see here now, PDB admin / this is a password @ PDB1, you can connect, sorry, Aura PDB1, right? So let me actually Aura PDB @ Aura PDB1. So why, okay, I don't have TNS entry, right? I should use this in the TNS. Okay, so I have to give the TNS entry of this and then I have to do it, else I have another way to do it. So here I would say localhost :1521 / Aura PDB1. So see, you are connected with PDB admin user to Aura PDB1 over the network. So how do I know this? You can just say show con underscore name. So you are connected to Aura PDB1. This is the beauty. So I'll also copy this here for your better understanding. Alright, so that is it. So what is that you have identified so far? Benefits is what I have to summarize. So reduced instance overhead, yes. Reduce redundant copies of data dictionaries, yes. Okay, so all DBA underscore data underscore files will be a subset of CDB underscore data underscore files. That's it. It is a fast provisioning. You can add a pluggable database, remove a pluggable database on the fly, optimize storage utilization, reduce upgradation time. In case if you want to upgrade CDB, all the PDBs are done. So better security options. Users can be controlled at PDB level as well as at the common level also. So CDB is a container which helps to consolidate all small non-CDBs into PDBs. So this is best architecture in case if you have multiple non-CDB environments of small sizes. So if you have such environment, get that into CDB architecture, you will save a lot of administration time. So it is interoperable with RAC. So it can also work with RAC. So multiple pluggable databases. So there will be a RAC course also which will be coming up for 12C. You can see that there. So when you upgrade the whole database with n PDBs, you achieve efficient of upgradation. So that is what I said. Enterprise manager will be fine and resource manager is extended between the PDBs as well. So resource manager is something that we did not discuss. And now one small thing before we conclude this session is this. What are the CDB configurations that you can actually create? Consider these are 3 different databases, servers. Okay. So what you can do is, you can in one particular server, you can create a CDB instance with PDB services. You can create a non-CDB database also called iProd and also ProdDB. This is another database which is non-CDB. This is also non-CDB, but you can create a one particular CDB instance called as one CDB1. You can create another database called as CDB1 as well. So that means in one particular server, you can have multiple container databases also running, not just one container database. Each container database can have multiple pluggable databases attached. So more than one containers also you can install, and when you install the container database, you can also run non-container database also. So that means in our environment, we can also bring up OraDB database as well, right? So that means in this database server, you will be having a, okay, memory target is not supported just because my memory is completely occupied by CDB environment. That's why. But you can have, once your server has enough memory, you can run CDB database as well, non-CDB database as well. And you can have multiple non-CDBs installed, multiple CDBs also installed. And each CDBs will have his own set of PDBs as well. Okay. And you can also have rack configuration also, right? You can have a rack instance. You know what is a rack instance, right? For a non-CDB environment, rack is there will be only one database for which multiple instances are connected. Similarly, you can have that for CDB environment also. You can have one database to which, one CDB and multiple PDBs can be attached. So each PDB can behave as a service, and that can run on each instances. That's it, as simple as that. Alright. So that is what I wanted to discuss: multi-tenant configuration, single tenant configuration, and non-CDB configurations. All these configurations are possible to install. Okay, so I'm going to conclude this session. So in this session, we mostly spent 10 minutes of time, or 15 minutes, sorry, 10 to 12 minutes of time at least on recap. And then we have done the overview of CDB. We have understood what is CDB exactly and how beneficial CDB is going to be. We have understood what is a pluggable database with a general, examples like flash drive, plug in, plug out concepts, utilizing the same resources, of your laptop or a system. And then we have, come back and we have installed the database environment. We have done some database checks as well. That is completely different from what we have done for non-CDB database. And then what we did is, we have seen benefits of it and different configurations which is possible. Alright, so that is what this particular topic will, this particular session is about. In the next session, we are going to cover architecture of your, CDB environment, why systems is orgs and all, how they are separated. And then we are going to speak about memory architecture and process architecture for CDB environment. Is it any different? And if it is different, what are new, what are not new? So all that discussions we will have. Alright guys, that's it for the session. So let us meet in the next session, covering up the next part of the same chapter. Bye bye.